So if we look at this circuit diagram, it's a little bit different than the other one. I realize that's really messy. But we see here that there is not one continuous loop. And what we mean by parallel is that the power, the energy here is still leaving the power supply, but when it gets to these little T's, okay, there's more than one path for this energy to choose from. The energy at this node, these little dots here are called nodes. Okay, nodes or branches. I prefer to call them branches, but you can use either one. Okay, it's like a fork in the road, and you can choose which path you want to go down. Okay, so what ends up happening here is the current can actually go in more than one direction. It can keep going this way, okay? It can keep going this way, or it can choose to go down towards resistor 1, right? This is still R1, this is still R2, and this is R3, same as we had in the last circuit, all right? And then when it gets to this second node or branch, it can choose to keep going this way towards light bulb number 3, or it can go down resistor number 2's path. So if we actually were to count how many loops we have here, how many possible loops or pathways do we have? We've got 3 possible pathways here. Okay, we've got pathway number 1, we've got pathway number 2, and we've got pathway number 3. Do you see that? So here's the interesting thing mathematically about a parallel circuit. I'm just going to make this a little bit smaller so I can actually write underneath it. Now, do you remember when we talked about Kirchhoff's law in terms of the total voltage of a series circuit? It's 1 pi that gets divided into however many resistors are taking certain voltage from that pi. The opposite is true in a parallel circuit. In a parallel circuit, total voltage, if I say that my voltage is set at 10 volts, total voltage here in a parallel circuit is going to be equal throughout. And what I mean by that is if I actually take a voltmeter and I put my voltmeter in here, okay, and I take a reading, I should have the exact same reading as my total voltage. And the same goes for the volt reading that would happen here, and the same goes for the volt reading that would happen here. V total, or total voltage, is equal to the same as the voltage read in V1, the same as the voltage read in V2, the same as the voltage read in V3. Okay, the voltage does not diminish because it's like saying you've got a simple circuit. You got 3 simple circuits here. Okay? They're just clamped one onto the other. So this light bulb is getting all 10 volts. Same thing goes for the resistor. Same thing goes for light bulb number 3. The voltage does not change. What do you think is going to happen with the current intensity? Do you think that's going to change? No. Yes, it does. In this case, the one that actually gets changed is the current, the total current. So I have my total current that I'm going to read on my ammeter at the beginning here. Okay, this is going to be total current. If I place my ammeter somewhere on this actual bridge, okay, in this actual path, if I actually add my ammeter right here, let's say, or right here, it doesn't really matter, okay, this becomes A1. If I then add an ammeter on my second branch, whether I add it here or here, this is going to become current intensity reading number 2. And then if I add it on my third branch, change colors here. Here's my third branch, and actually the third branch goes all the way around here. I could put it here, here, doesn't really matter. This becomes a 3, or ammeter reading 3, current intensity 3. So I total, in this case, is going to be equal to the sum of all of the current intensities. Okay? Now, if I look at this versus what I had here, do you see a relationship? Okay? If we have a series circuit versus a parallel circuit, let's kind of put it all on the same page here. In a series circuit, you're only going to have one loop. Doesn't matter how many resistors you have on that loop, but you only have one loop. Okay? One loop. How many loops do you have on a parallel circuit? More than one. Okay? So you have greater than one loop. Okay? You have 2, 3, 4, 5, doesn't matter. All right? What else do we know about series circuits? What happens if one resistor stops working? They all stop working. What happens if one resistor stops working in a parallel circuit? Just that resistor stops working. So if we want to compare a series and a parallel circuit, okay, there's some comparisons here. We know that in a series circuit, we only have one loop, which is why when one resistor breaks, the whole thing shuts down because there's only one loop. The current can't keep going. Okay, whereas in a parallel circuit, you've got more than one loop, 2 or more. So if one loop breaks down, there's still more loops to work. Okay? We know that in a series circuit, total voltage is shared by all the actual resistors. So V total is going to be equal to the sum of V1, V2, V3. Whereas that's not the case in a parallel circuit.